Hey, and welcome to this session about implementing customizations for Microsoft Teams using Azure PaaS services. My name is Laura Kokkarinen. I work as a senior developer and a solutions architect at Sulava in Finland, and I'm currently focused on implementing solutions on Microsoft Cloud, namely Azure, Microsoft 365 and the Power Platform. I'm also a Microsoft MVP in the Office Development category, and if you would like to follow me on social media, you can find me on all of the platforms by my name. And in this session, I want to answer to a few questions, and they are: why and when should we extend Teams? What are the different app types and the extension points that we can use? And how does Azure Platform as a Service relate to all of this? Let's get this show on the road.
I think at the moment a lot of people haven't realized the potential Teams has as a development platform. When people need to implement some kind of a new application, they just do what they've always done and implement the functionality somewhere else. But don't you think it would be such a shame if Teams actually was the most beneficial place for having that functionality, and that people don't implement Teams applications just because they don't know what can be done? Especially when the information we need for performing a certain task is already being processed in Teams, it would just be an extra step if we were to take that information somewhere else. I'm hoping that the more we educate each other about the possibilities Teams offers for application development, it will become much more popular amongst customers. We can't customize Teams in just any way we please. However, it works in a very similar manner to the modern sites on SharePoint Online. There are extension points that allow us to insert customer content and behaviors to enrich the core product. The different types of apps are available at different extension points, and in this session we will go through what are tabs, bots, messaging extensions and webhooks, how they work and are implemented, and which extension points they can be used from. Tabs allow us to add new views to Teams. They are our most broad option for editing the user interface, as you can't extensively modify how Teams looks outside of them. Tabs typically work in the context of a team. You can add them to a channel and they appear as a tab there the same way as posts and files do normally. Behind the scenes, tabs are basically web pages. If you can imagine something you would like to get done as a web page, it can be brought into Teams as a tab. The same applies to already existing web pages. So if you have a website for doing something and you would just like to bring it closer to the user in Teams, it's merely a matter of configuration to make that happen. A natural place for hosting your tab is in Azure. There you will need to create a web app, and with that comes an app service plan. And those are the two basic resources you need for setting up a tab in Azure. So you see, a tab is just a web page or a website hosted somewhere else, in this case Azure, and it is brought into Teams by linking to that website in a configuration file called the manifest. The manifest file is a JSON file that is packaged into a zip file together with two logo images that represent your application. The zip file is then installed to the Teams app catalog. And you never install any code or binaries into Teams. You only upload the manifest file and the two logo images, and the code always lives somewhere else, and you just link to that web application from that app manifest in Teams. And this is how it works for all of the different application types. In addition to creating standalone web applications and hosting them in Azure, you can also create tabs by, for example, creating an SPFX web part or a Power App. The web part is hosted in SharePoint and the Power App is hosted in the Power App service or whatever that's called. Then let's move on to bots. Bots allow users to trigger background operations in a conversational manner. A bot can potentially be triggered via all the different types of conversations. So there's the one-to-one chat, group chat, and channel conversations. The bot typically has a set of commands the user can choose from, which helps the bot to understand what the user wants to do. In this example picture, when the user clicks on the new request button or types in new request to the chat, the bot proceeds to offer the user a form to fill. At the core of the bot is a background web service which does the actual work behind the scenes. So when a user talks to the bot, the user's message is sent to the background service, which then does something, basically anything you want it to do based on that message. And after doing whatever we want the background process to do, the bot can send a response back to the user in Teams. And this whole background service can be coded precisely the way we want it, and the bot is basically just our way of triggering that background process. For creating bots, you want to create a web app bot in Azure, which basically gives you 3 resources: the bot service, a web app, and an app service plan. When you initially create the web app bot, it gets created with the S1 app service plan, but you can immediately, after creation, downgrade it, so you don't need to pay a lot of money for running the web application while you're developing. Of course, for production, that's another thing. This is just something that you need to remember to do, especially if you don't have any free Azure credits at your developer tenant. Now let me show you a demo of what I just told you. So in Azure Portal, go to Create a Resource and search for Web App Bot. There we go. And then click on Create. Give it some kind of a descriptive name and select the subscription that you want to use. Possibly create a new resource group and select a location nearby. Pricing tier to free. And the app name is available, which is great. And I'm going to change this to Node.js because I want to use Teams for generating my project and use Node and TypeScript. And then let's create a new app service plan for this and use the same name as for the app itself. And again, select the same location. And you can see here that it's warning you that it's going to create the app service plan with S1 and that we can downgrade after the app has been created. And then let's change this to West Europe as well and then create. Okay, it took a couple of minutes for the resources to get created. Let's first go to the app service plan and downgrade it so we are not racking up any additional costs. There, the free tier is totally sufficient for development. Now that that's done, let's go to the bot service and then settings. Here you should take note of this app ID, put it in a notepad, and then let's click on Manage. This takes us to the Azure Active Directory app registration, and here we'll create a new secret and also copy this temporarily to the notepad. Then let's go back to the bot service, and this time let's go to channels, and here we want to add the Teams channel to this bot. We just click on save and agree to these terms, and that's it. Then I've already created a folder in my desired location for this new bot project, and I've previously installed this Teams generator on my machine, so I'm just going to run this command Teams. The generator will ask me a bunch of questions and then generate the project structure for me, and then I'm able to continue from there development by using TypeScript. Yeah, this folder name is totally sufficient as my solution name. I want to use the current folder. Let's call this something else, like this. Yep, that's totally fine, and let's use the latest version. I don't have a partner ID, and we want to create a bot. Was this my host name? Let's check that. Nope, it was this one, so I'm just going to copy this here, like so. For this demo, I'm not going to include these. Yep. This is my bot name. And now we copy the ID that we got before over here. And I don't want to add a static tab, another support file. And now the generator is generating our project structure for us. It's going to take a couple of minutes. Okay, now the project has been generated, and let's hit code dot to open Visual Studio Code. First, let's go to the environment file and add the application secret or client secret that we created earlier over here, and click Save. Then we want to run a bunch of commands like gulp build. Then we want to run gulp manifest, which basically generates the manifest JSON file for us based on the settings that we have chosen. It can be found here. And finally, we want to run gulp ncroc serve. This will start the ncroc tunneling service. You need to download the ncroc.exe file first, and then it will also serve your application, so you can debug it. And what we got here is the ncroc URL that we need for debugging our bot, and where we put this is here in bot settings. Here's normally our web app URL, but for debugging purposes we are going to change that to the ncroc URL. And then another thing we need to do for debugging is to go to Teams and then Apps and upload a custom app. And what we're going to upload here is this zip file that we generated with the gulp manifest command. And that's it. We click on that and click Add, and it will open the bot. Now it has this help command. Let's see what it does. I'm just a friendly but rather stupid bot, and right now I don't have any valuable help for you. That's pretty cute. And that comes from when we go to App, and where was it? Here. So these are basically the bot events on message, on conversation update, and on message reaction. And inside these, you add your code to do whatever you want to do. And here we can see that when the context activity type has been message and the content has been help, then it will create this dialog, which is here. The bot also knows how to do some other things like respond to hello, and then it apologizes if you try anything else, so let's give that a go. That's nice. What about bye? You should know how to respond to this. No. But yeah, you can see how that goes. Then other things it can do is on conversation update, for example, when a member is added, it will show that kind of an adaptive card that we saw in the beginning. And then if I like one of the messages, then it will react to that. So let me just demo that. So let's like it. There we go. So yeah, that's basically what you need to do to set up a bot for debugging. And when you are done with your application development, then you update the URL back to your web app URL and publish your code to the web app that we have here. The classic bot scenarios also use other Azure services, such as those under cognitive services. And yep, you quite often will also use other Azure services in addition to just the web app and the bot service. But what services you need to use always naturally depend on the specific application requirements that you have. You also have an alternative technology for implementing bots, and that is PnP Virtual Agents. However, those are really expensive to run. If I remember correctly, the starting price was something around 1,000 euros per month. So even if it would take you longer to code the bot than create it with PnP Virtual Agents, you should really think about it in the long term, how much it will cost for the customer. So it will probably in the end be cheaper for you to code the bot and run it with a lot less maintenance costs in Azure than create a PnP Virtual Agent bot. To sum it up, bots are excellent when the task feels the most natural to perform in a conversational manner. You shouldn't necessarily use bots just because they're cool, but, think about what's the most natural way for the user to perform a certain task, and sometimes bots can be the most natural way. They can be good also when you want to create this kind of a chat relay application, like in these pictures, where the user is talking to the bot and the bot is relaying the message to a team where any team member can respond to the user. The same approach could be used in a web chat situation where a customer would be talking to the web chat bot and the employee could receive the messages and reply to them from Teams. And it also offers us a chance to keep both the users anonymous if we want, because both of them are just talking to the bot and we don't necessarily need to reveal the users' identities. These could be useful in, for example, feedback or support scenarios if users are afraid of bringing up some topics with their own name, or we don't want users to contact individual support team members directly, for example. And finally, bots are also the way to go if you want to create a personal incoming webhook for notifications, because the normal incoming webhooks are only available within Teams. I'll tell you a little bit more about incoming webhooks later. Then, personal applications. In addition to having bots and tabs on channels, you can also pin both these app types to the left-hand navigation. When you do this, they are called personal apps. Personal apps are basically apps outside of the team context, hence they are called personal. A user can use them regardless of what teams they belong to, and they are a great way to easily offer a tab or a bot to a large number of users who can't belong to any one team. How they work is that the custom app icon is pinned to the left-hand navigation the same way as chats, teams, etc. normally are, and the less frequently used applications can be found behind the three dots. You can use the Teams app setup policies to find which applications are shown to which users. So if you have different types of users and you would like to pin different apps to the left-hand navigation to different types of users, you can totally do that by using these Teams app setup policies in the Teams admin center. To compare, channel tabs are good when you want to show content that is related to the team or the channel where the tab is added. And personal tabs are good when you want the view to be easily accessible regardless of which teams the user belongs to, and the displayed content is not related to any team level activities but is more independent. And the benefit of having a bot as a personal app is the easy discoverability. It's a lot quicker to find the bot in the left-hand navigation compared to going to the chats and scrolling through all the different recent conversations to find the bot conversation that you had earlier. Then, messaging extensions. Behind the scenes, messaging extensions work in a very similar way to bots. There's a background service that is triggered by Teams, and then it does something, and then possibly sends a response back to Teams. However, bots and messaging extensions are triggered very differently. You can trigger messaging extensions in 5 different ways. You can mention them in the search box at the top. You can mention them in the compose message box, or you can click on the 3 dots at the top right corner of a message and then select more actions, and that will reveal your custom messaging extension actions. Or you can select the app icon below the compose box, possibly behind the 3 dots. And then one way which is not present in this picture is that when someone posts a URL address from a specific website to the chat, that can also trigger a messaging extension. When a messaging extension is triggered, it can open a pop-up called a task module. I'll tell you a little bit more about these later. You can use the task module to collect additional information from the user before sending the data to the background service for processing. In this example picture, clicking on the Add a To-Do action would first open a pop-up where the user would specify the title and dates for the task. Then the data would be submitted to the background service, and after that the message extension can reply back to Teams and show a similar pop-up again, saying, for example, success, or include some specific text or an adaptive card in the compose box where the user is typing the message. How the messaging extension should work can be quite different depending on which extension point you are using. So I would recommend that you try out some of the existing messaging extensions that are available from all of these different extension points and see what their user experience is like, and hopefully you get some ideas for your solution. Messaging extensions are good when you simply want to trigger a background process without implementing an extensive user interface, and triggering the process feels the most natural from one of these extension points. Or if you want to trigger a process when someone posts a link from a specific website to the chat, then messaging extensions are the way to go as well. In addition to using the Azure services, you can these days also create messaging extensions for that More Actions menu by using Power Automate. For that, they are extremely easy to do. For me, it took just 5 minutes to make that Add to Do messaging extension with Power Automate. I highly recommend that you go and first check if you can easily implement what you want to do with Power Automate before you start coding your messaging extension from scratch. By the way, this is quite a new feature. I think it was released in July. So yeah, if you haven't checked that out yet, go and do that. Then webhooks. So if you are just looking for a simple way of integrating an existing external system to Teams, then webhooks can offer you a very quick and easy solution to that. There are 3 different types of webhooks. Outgoing webhooks for sending a message from Teams to an external system. Incoming webhooks for sending a message from an external system to Teams. And then connectors, which are basically productized incoming webhooks by you, Microsoft, or third parties. So as I mentioned, outgoing webhooks allow you to send messages to external systems from Teams. They are used in a very similar way to bots. You mention them on a chat or channel and then type your message. The difference is that when you send the message, it will go directly to the external system or service, for example, your HR system. The external service then does something based on the message and can even reply back to the user in Teams. This reply message can even be shown as an adaptive card if desired. I'll tell you a little bit more about adaptive cards a bit later. This means that you can offer a bot-like user experience, but still the user is merely talking to an existing system or, for example, an Azure function. It's excellent if your external system already offers the URL where you can send the message and knows how to process it, and even send a message back into Teams in the format that you want. However, it is more likely that all the required functionality does not yet exist, and in those cases it needs to be implemented, which falls down to the organization who offers this external system and its application programming interfaces. If for one reason or another the external system can't offer the functionality in quite the format that you want, it's always possible to have a middle layer in between Teams and the external system. In that case, you would not be using a webhook, but for example a bot from Teams for relaying that message between Teams and the external system. You could then perform those additional operations regarding, for example, message formatting in your bot, instead of them having to be implemented in the external application. To sum it up, outgoing webhooks are good when an external system or service already exists and offers a URL where we can send the message for processing, or we are creating a brand new system or service and it makes more sense to create an API than a bot. So other systems could also use the API. Azure functions are also cheaper than running a web application, so that's also one thing you might want to consider. Incoming webhooks work in the opposite way to outgoing webhooks. They allow an external system to send information to Teams channels. It's very straightforward to add an incoming webhook to a channel. You basically just add the incoming webhook app to the team and then specify which channel you want to add it to and what do you want to call it. Or alternatively, you can click on the connectors for the channel that opens the same menu. You can also optionally upload an image as its icon. Upon creation, you will receive the URL address where the external system needs to send their messages for them to appear on that Teams channel. That's all there is to it on Teams side. However, some code changes might need to be made to the external system for it to construct and send messages to that URL. Incoming webhooks are useful when an external system already exists. We only need to add a small piece of code there to have it send messages to the channel URL. But keep in mind that incoming webhooks can't be added to one-to-one or group chats. And as I mentioned before, connectors are just productized incoming webhooks. They can either have been created by you, Microsoft, or a third party. The webhook has been packaged into a Teams app and then made publicly available in App Source. There's, for example, a GitHub connector which can send notifications from GitHub to a Teams channel, and even the incoming webhook app is considered a connector. Connectors are good when you want to package your incoming webhook into an app so that it's more easily discoverable and usable. Then, additional things you can include in your applications. You've already seen quite a few adaptive cards during this presentation. They basically offer us a way to format the messages that we want to display on chats and channels to the users. They can be used from bots, messaging extensions, webhooks, from all the different kinds of apps that allow us to send messages to chats and channels. They allow us to define the structure of the message, what info to show, in which order, in what format, and it's also possible for us to include buttons and links in the messages that the user can then click for further actions. The messages are essentially JSON markup following a certain schema. You can create card layouts by using a tool called the Adaptive Card Designer. It will automatically generate the JSON code for you, which you can then use in your application. There are also different kinds of adaptive card templates available online that you might want to check out first before you start from scratch. Adaptive cards are good when you want to show a chat or a channel message in a certain format, or you want to offer the user buttons for quickly performing additional tasks. Then finally, these task modules that I already mentioned earlier. They are these kind of modal windows that you can open in Teams. And they are great when you want to display or collect information from the user through that kind of a temporary pop-up. We can open task modules by clicking on buttons, links, or other elements we've included in a tab, or by clicking on buttons or links on adaptive cards. These could have been sent to a chat or a channel conversation by a bot or a messaging extension. You can also open them by clicking on a Teams deep link. The link can be clicked by the user anywhere, even outside of Teams, and it then takes the user to the task module view in Teams. The key things to identify before implementing Teams apps are: do we want to display information or trigger a background process, or both? What place in Teams feels the most natural for the user to view information or trigger the process? And what technologies do you want to use? Do you feel more comfortable with some technology or language, or do you perhaps want to go outside of your comfort zone and learn something completely new? These are the things that you need to consider before you start implementing a Teams application. Now let's finish this session by going through the technologies we can use for implementing these different app types we just went through. On Azure side, you should first familiarize yourself with the web app, bot service, and app service plan resources. When you proceed to design or implement your actual app, you might also realize that you need to look into some other Azure services as well. When it comes to languages we can use when we develop these apps to be run on Azure, I would say that look into TypeScript with your teams for implementing the tabs. There's the Fluent UI React NPM package included in the project, and it allows your tab to have the Teams kind of look and feel. You can use the TypeScript and your Teams for bots and messaging extensions as well, but if you're more familiar with C#, you might want to rather use Visual Studio with the new Microsoft Teams toolkit that offers Teams app project templates. That was just released this summer, so make sure to check it out at some point. You will also need to get and learn to use a tool called ngrok for debugging your bots and messaging extensions. And here are the other technology options that I mentioned. If you are familiar with SPFX, it might be quicker for you to implement tabs as SPFX web parts. And if you are looking to implement messaging extensions that get triggered via the More Actions menu, definitely check out the new Power Automate trigger. Thank you very much. Make sure to give some feedback and check out these additional resources as well. Bye bye.